Okay, well, welcome everyone to our Messana webinar. My name is Eva Rooks. I'm the Marketing Director for Small Planet Supply, and I'm excited that today we're presenting our first ever Messana webinar. For those of you who are new to Small Planet Supply, we are a North American company dedicated to the mission of creating both classic and modern high-performance buildings. In keeping with this mission, we provide materials and education to building industry designers and builders in the use of toxin-free, energy-efficient building materials, as well as energy-saving mechanical systems, including now Messana. We've got a lot to cover today, so I'm going to do quick introductions and a bit of housekeeping, and then we'll get right to the presentation. Our presenters for today's webinar are Alessandro Arnolfo and Brian Rossi. Alessandro Arnolfo is co-founder and CEO of Messana Radiant Cooling. So if anyone knows about this product, it's him, and Brian Rossi as Senior Applications Engineer at Messana. On the Small Planet Supply side, we have Peter Reppy, who's our systems engineer, and he is the Zoom webinar Q&A rockstar. I think he's been on more webinars than anyone in our whole staff. And also we have Josh Palmer, who you don't see, who's our video production manager, who'll be helping us with all things technical and be producing a cleaned up version of this video. Regarding the presentation, you may notice that there is a chat box and a Q&A. Please use the Q&A for the questions. That way your Q&A will be available after the presentation. If you accidentally use the chat box, we'll be able to get you a reminder to switch to the Q&A just for that reason. So with that, I'm going to go ahead and hand this off to Alessandro.
All right, thank you so much for the introduction. So once again, my name is Alessandro. I'm the CEO and one of the co-founder of Messana Inc. You introduced us as Messana Radiant Cooling. Now we go by the name of Messana Hydronic Technologies, and we are a worldwide leader company in the HVAC hydronic industry. And yes, we are known as the radiant cooling guys, and so we have been doing business as Messana Radiant Cooling for many years, and we are one of the major pioneers of the radiant cooling technology in the world, and in particular here in the US. And Messana is a company that manufactures radiant ceiling panels. They go under the brand Raymagic. Then we also have a climate control platform. The name is M-Control. And we also manufacture, actually are manufacturer in OEM for us, air treatment unit. And you'll see later that, treating the air during radiant cooling, it's key. The company also provide engineering and design services for we call it like a boutique service. It's addressed for its high-end residential hydronic system. So basically, we do all the panel layout, all the design of the hydronic system. We design the control system. It's a custom design for high-end residential, and we also design the ventilation when it's needed. So we operate mainly in the residential market, but we also cover the commercial market, and we are a company that operates worldwide. We are right now, our address is radiantcooling.com, and I was supposed actually to show these slides. So we are now moving into this new branding that started last year and will be terminated in 2022. And so we will be calling ourselves Messana Hydronic Technologies as a new DBA, and we will transition all our website and domain as Messana Tech. Let me give you a little bit of history of 31 years of experience, basically in hydronic, in particular in the radiant cooling technology. We started the first experiment in radiant cooling on the floor in back in 1991, 93. And soon we realized that to do cooling, we need to look up in the ceiling. And we, in 98, released the first worldwide patent for radiant ceiling drywall panel. So there was a drywall panel, it was very thick, like an inch thick, and we were routing a serpentine and then putting the pipe into the drywall. It was a very basic technology. About 10 years later, then we created a new technology that still go under the name of Raymagic. And basically this evolution was, instead of routing the gypsum and putting the pipe embedded into the gypsum, we created a sandwich structure. So there is a substrate of EPS with aluminum and the serpentine, and then the gypsum panel is attached to this sandwich, and it's like a lamination, and then we engrave on the gypsum the serpentine, so that when they install the gypsum on the ceiling, then they don't heat the pipes. In 2011, I started the business here in the US. Initially, it was Messana LLC, and it was more a commercial company to establish the marketing, the market of radiant cooling in the US. 5 years later, we converted in Messana Inc., and we started the DBA Messana Radiant Cooling. And the same year, we released a new patent. It's a patent on a quick coupling joint technology, which is currently used in our Raymagic panels. It's a sliding joint technology that allows to use PEX pipe. And as I already mentioned, in 2021, last year, we start this rebranding process into Messana Hydronic Technology. And one of the reasons of this choice is because we grow fast in the control HVAC hydronic control industry, and we progress in controlling radiant floor, controlling fan coil. So it's not all about radiant cooling anymore, and still radiant cooling is one of our major expertise and activities, but we want to be recognized as a leading player in the hydronic market here in the US. Since the first ceiling installation in 97 up to today, 2022, we have thousands and thousands of installations worldwide, and Europe, North America, Asia, something in South Africa. We have a few installations in Australia, many installations in New Zealand. And I would say that as number of installation, 20% are commercial and 80% is residential, let's say high-end residential. In the picture here, you see some picture of the factory we have in Italy. And here I have the Messana distribution partners. As you can see here on the left top corner, new for 2022, we are happy to partnership with Small Planet Supply here on the West Coast. And in the West Coast, we also have a CHC, which is a partner that does commercial for us. And then this is where we are based, Messana Hydronic Technology, you know, Messana Inc. It's in California. Then we have a OEM partner in UK. They go under the name of Radiana. Then we have a partner in Italy that now they are called Messana Italia. We have Vivaldi, which is a partner in China, Waterware, great partner in New Zealand, and then we have two partners in Australia. We sell all over the world, and where we don't have partner, we sell direct. We own our own manufacturing plant in Italy. It goes under the name of RAM, which is Radiant Architecture Manufacturing. Is an Italian company, and they do OEM manufacturing of prefabricated radiant panels. Okay, so now I go a little bit more on the technical details to introduce a few concepts about radiant, in particular radiant cooling, and then I will let Brian to go over our product. So as I said, we were pioneer in the radiant cooling technology, and often we're asked, what is radiant cooling? And radiant cooling does not exist as a physical phenomenon, so there is not such radiant cooling. Radiant heating, it's a phenomenon, it's a physical phenomenon, but no radiant cooling. So if I have to describe radiant cooling, I would say it's negative radiant heating. So basically, radiant cooling is based on radiant heating reverse. So basically heat extraction. So with the name radiant cooling, it's not a physical phenomenon that we are describing, but we are describing a technology to cool buildings, and through heat extraction. So in the picture that you see, basically, you can see on the picture, there is on the ceiling, there is a imaging panel. And so if we run cold water through the panel, we will be cooling the surface, the ceiling surface. And because heat seek cool, so there will be radiation between every object in the room, like this screen will be warmer than the ceiling, and there will be energy that is thermal radiation going from the TV to the ceiling. And same thing for these apples and the floor and this lady on the couch, and the lights are radiating. So every single surface in the room that is a temperature that is greater than the ceiling will radiate, and the ceiling basically is receiving all this radiation, and the water, the cold water, get warmer, and then is sent back to the heat pump to be recooled. And so this is basically extraction of heat, and so the result is that the temperature in the room will go down. And one of the reasons why we prefer to do radiant cooling on the ceiling, there are many, but one of the most important is that when you do radiant cooling on the ceiling, there is also a component, there is a convective component, so cold air moving down. And this is happening because the hot air rises, hot air is trapped on the top, on the ceiling, and in contact with the cold ceiling, the air, the first layer of air will get cooler, and then the cooler air will move down. So typically 30% of the system, the cooling system, will be by convective air. So this is one of the reasons why it's important to go in the ceiling. There are many other. In the ceiling, the surface is unobstructed. There are no furniture, carpets, so you don't have to deal with the flooring. And then by integrating this technology in the gypsum, makes the system reacting very fast, and this is very important for radiant cooling. However, on the ceiling, we can also do thermal heating. So basically, if now we run hot water in the ceiling, what happens is that the ceiling surface becomes warmer than the temperature on the surface of the TV, of the Apple, of the window, of the couch, of those, and also the floor. So basically, in this case, there is radiation going the other way around. So from the ceiling to the TV, to the Apple, to the floor. And as you can notice, there is this orange wave from the women going back to the ceiling. And this makes me think that the ceiling temperature is less than 98 degrees. I mean, typically our body surface temperature is in the 98. And so that means that if, let's say, the ceiling temperature is 90 degrees, which would be a common temperature for a radiant ceiling, then still there is energy from the woman going up. So this is very typical. So to cool a person, not necessarily the person is receiving radiation. It actually goes the other way around, and the feeling of heat is because we radiate less to the surroundings. So, and still give us a feeling of being heated, but reality is that we are still radiated. So this picture is showing that, yes, heat does go down. We have been asked many times, so how can you do heating from the ceiling? And the answer is radiation doesn't care if it's on the ceiling, if it's on the floor. It's just a radiation. Just think of the sun. It's on our head, and still the sand in a sandy beach will be hot. So radiation really doesn't care of gravity. It's not a gravitational thing like the hot air that moves for gravity. And so this is the same ceiling again back in cooling, and where we are running cold water in the ceiling, and here the radiation are going the other way around from the TV, from the Apple, from the floor, and everything goes into the ceiling, and then the water, the hot water from the heat pump get warmer, and then is pumped back to the heat pump. And so this works as an extraction of heating. So I have now given you like a quick introduction on radiant heating, radiant cooling, radiant ceiling, and then I let Brian taking over the presentation, and he will go over more in details, and in particular will show you all the product that we manufacture and we will be offering with Small Planet Supplies.
So my name is Brian Rossi, and I'm an application engineer here at Messana. So I primarily deal with designing systems, doing panel layouts, doing mechanical room layouts, helping customers design the control platform, dealing with support issues and so on for the system. So what I want to start is kind of work our way through the different products that we offer, and that Small Planet will also be offering available soon, hopefully coming up. And so to start things off is the panel. So we consider ourselves a leader in gypsum radiant panel technology. We have multiple different patents, mostly surrounding the fittings that are on the panels. What you see here is the NK panel on the left, the behind drywall or gypsum panel, can also go behind wood. And then on the right-hand side, you're seeing some options that are on the commercial side of things, which are metal panels, gypsum panels, which is the small white one that you're seeing there, as well as wood options. We have pretty much endless ideas on what you can do with its a surface that we can typically make it an active surface. Let me go to the next slide here. So the NK panel, this is the panel that we will be having Small Planet using in distribution, which is the most commonly used panel in residential applications. We do use it in commercial as well, but not as common. But this panel goes behind drywall. So this panel gets installed prior to drywalling, and then you can cover it with drywall. You can cover it with wood. It can also, other approved materials. We've been seeing some other new options with magnesium boards instead of drywall that have been coming around. And essentially what this is a 1.5 inch EPS formed board. It has aluminum heat transfer plates. And the unique thing about our heat transfer plates is they have a unique proprietary omega shape that allows for more contact with the PEX serpentine inside the panel. So we get faster and better conduction through the PEX to the aluminum plates. Then there are 3-way snap-in fittings. These are a fitting that allows for expansion and contraction in the panel. And this fitting is one of our patented parts in this panel. And this allows for the inner PEX to move once the panels are locked and screwed into place, so that we don't have any issues with expansion contraction going from heating to cooling and so on. It's got 2 5/8 inch PEX backbones for the supply and return lines inside of the panel. The 2x8 essentially has 2 embedded hydronic circuits. The 2x4, the smaller panel, has only a single one in it. This is designed for 24-inch on center furring channel installations. So it can go between 24-inch ceiling joists. It does make the installation a little bit more limited. You have to stick wherever your ceiling joists are installed. When the panel goes up, you have to make typically more penetrations in the ceiling joists for the piping. So which is a big reason why we like doing a furring channel, which I'll show some pictures of shortly here. And the other reason we like this panel a lot, we used to, and we still do sell a lot in Europe, another version of the panel that comes with gypsum online. And those gypsum panels, they were installed all together. So the gypsum was already attached to the panel, and we noticed a lot of issues with trades and separation of trades. And so this panel is nice because essentially the builder can put up the furring channel where they need it. The panels go up, they get pressure tested with air, they get water put in them, any leaks and so on can get dealt with right then and there. And then once the system's ready, they can go ahead and cover with drywall. And then, you never essentially see the panels at that point. Now, the 2 capacities we show here are with different water temperatures. This particular panel is about 21 BTUs per hour per square foot, and that's with 55-degree water, which from a heat pump standpoint, that's a really good water temp from an energy consumption usage. They're going to get really good efficiency numbers with 50 to 55-degree water. We can go all the way down to 46, but typically that, it tends to be a little bit harder to maintain that temperature, and it's a lot not quite as efficient on the heat pump side of things. And same goes with heating. So 24 BTUs per hour per square foot with 100-degree water. And both of these numbers are assuming 5/8 inch gypsum or drywall on the ceiling. So if you do choose to do 1/2 inch, you'll get about a couple % better than that. So here you'll see a rendering of an installation here. And so essentially imagine the ceiling and the house was built just like normal with no expectation of these panels going in. And then after, they can come in and they can add 24-inch on center spaced furring channel. And that furring channel could be a wood 2x2, or it could also be a metal hat channel. And the perk to this is that essentially wherever we need to have lighting or speakers, we can essentially leave a gap there, and we can make it smaller than 24-inch on center if we need to. We can make it larger and so on. So it gives us a lot of flexibility with avoiding and making channels for lights and speakers. Now, the panels, we do not typically need to cover 100% of a ceiling. Typically, you're looking at 60 to 70%. It all is going to depend on the loads for that particular building and the building design. So typically we can have no problem avoiding lighting and speakers and so on. However, if you do need to put a light into the actual panel because maybe you've got a room that's got extremely high cooling loads, which are typically the loads that drive most of our designs, versus heating. Typically we see heating covered well over 100%, but cooling side of things, especially with houses with a lot of glass, a lot of glazing, then we're going to end up to sometimes needing to cover a larger than 60 to 70%. And that's where you might have issues with lighting. then we can allow up to a 3-inch diameter hole to be cut in the panels within the serpentine. So there are some lights out there that are good options in the LED side of things that, you know, down to 2-inch lights that you can easily fit in. So I'll show, here's a picture of an installation going up. So this was using a 2x2 wood furring channel. And in this case, the wood's a little bit more convenient in some aspects. It's not a straight, but it is easier from hanging the panels because you can use simple staples to put the panel up. And the way the panel goes, it goes in between the furring channels. So essentially that 1.5-inch foam is filling that void and having a backer of the joist, the ceiling joist behind it. When you receive the panels, they come in boxes of 5. You're going to get them. They're going to have an extra piece of EPS foam that you essentially see on the sides here. When you go to install them, you actually snap that EPS foam off. And what that's doing is exposing a wing of the aluminum plate there. And that it gives you a spot to screw if you're doing a metal hat channel, or staple or screw if you're doing on a wood hat channel. So here's a picture of a room that is after an installation and actually monitoring and seeing what we're getting on the actual panels. Typically, we stick to just ceilings. These panels can go on walls like you see in this. There is some panels on the right-hand side above that entryway into this room. Typically, those are the kind of spots that we might see it. So this room has a lot of glass and was southern facing, and it had fairly high cooling load demand. Because of that, we covered the ceiling almost 100%, and we also put some panels on the wall back there. And typically on walls, we're only going to want to see it usually on, you know, where you've got high vaulted ceilings or something like that. And so that typically those are places that people aren't going to hang a picture, or they're not going to be, you know, typically putting a hole in the wall at some point later on down the road. If for some reason anybody ever does need to do it, the easiest solution is you can buy a thermal camera from Fleur. They make ones that plug into your phones nowadays. They're fairly affordable. And most of our clients end up typically buying one, and they use it to, if they think that they have a mechanical issue that might be going on, or they think that there might have been gotten air in a line, it can help a lot with diagnosing issues. So that can always be used to see the serpentine, turn the panels on, see where the serpentine, mark where you want to make your penetration after the panel's been installed, and you can easily do that after the fact. Now, the big part of doing radiant cooling especially is the control aspect of things, because heating, we can send whatever water temp we want to it. We actually do fluctuate the water temps based on how many zones are open, how far we're off from set points to make the system more comfortable and more efficient. However, with heating, theoretically, we could just send 120-degree water and it doesn't really matter. And then when we don't want heating anymore, we take it away. We don't have to worry about condensation side of things. With cooling, it's critical that we're monitoring the environment. We're monitoring dew point, we're monitoring temperature, air temp, and we're taking all this information and we're making sure that based on how long the panels have been on, how many zones are active, what the supply temperature is, what the return temperature is, and we can fluctuate this water temp to make sure that the ceiling surface stays above the dew point. Now, because we know our panels so well, we're also able to technically at times run colder water than what the dew point actually is, because there is a temperature gradient from the water side of things out to the actual surface of the panel. So typically we're looking at between 5 to 7, 8, sometimes 10 degrees when they first turn on. And so based on how long the panel's on, we can anticipate what that is to avoid condensation. The other side of things is controlling the air if needed through, you know, air units of some sort, whether it be dehumidifiers, humidifiers, mechanical ventilation. So these are all different sides of things. And this M Control platform is an overall hydronic control system. And so we do radiant floors, we do radiant ceilings, we do combination systems, we do heating only, we do heating and cooling, 4 pipe systems where rooms have heating and cooling at the same time in different areas of the house, fan coils, and some integration with different types of VRF systems at times. So the 2 big main boxes that we're going to be selling through Small Planet are going to be the MBox 5 and MBox 10. These are new, along with the NK panel and the 2x8 and the 2x4 for this year. We're still in the process of getting all the documentation together for these. They haven't formally fully been released yet. So we've gotten prototypes done on these. These are newer iterations of previous controls that we still are selling now. And this box is a standalone box. Both the 5 and 10 are. The 5 is a 5-zone system. So you can do up to 5 different zones. However, you can do more loops than that. Typically, we allow up to 3 actuators on a single digital output in the control, which would open and close that thermal actuator on a manifold, either going to a radiant floor, radiant ceiling, or a zone valve to a fan coil. These are going to be really unique in that everything is in one. So a lot of different control options for hydronics. You buy one type of control module, then you buy multiple different zone modules, which we have a very similar in our overall custom M controls platform. However, we've put everything into a single one. So you've got relays for turning on and off pumps, powering those pumps. You've got digital inputs. You've got, in case you want a door sensor or a window sensor to disengage a zone's heating or cooling. Or an alarm from a heat pump outside, or an alarm from a boiler. We can control a variety of pretty much any type of heating or cooling energy source. So whether it be a boiler, a gas boiler, or electric boiler, electric backup, heat pump, anything that we can control with essentially a dry contact. So shutting and closing a simple contact. These are made up of industrial grade components in them. So everything is essentially replaceable in these. If you ever did have a power supply failure, anything like that, we can easily remove that and replace that part without having to completely replace the entire control box. So it offers a lot of flexibility with long-term maintenance if there ever is any. This is going to allow the installer to essentially go through a wizard. So when the controls, they'll power it up, they'll connect to it via the app, which we have for iOS, Android, and we also have a web browser-based version. They will go through essentially an interactive configuration wizard. And what this wizard's going to do is it's going to prompt them with questions, ask them about certain parameters of the system that they will be using this control module for, and then it will program itself. So it will assign, based on what you've given it, which digital outputs you're going to use for your different zones, where to connect your sensors, and in this case, it would be an M-Sense sensor from us, and then also where you need to connect strap sensors for reading pipe temperatures, a well sensor for reading a buffer tank, where you connect for the heat pump connections. So this gives you some different options. The MBox 10 is essentially exactly what I just described, except up to 10 zones. So it's a larger box for larger homes. These are limited to that number of zones. If it's a larger home than that, then typically in that case, we'd have to go on to our more custom modular system, which includes MBox and zone modules. And that's essentially pretty much infinitely expandable. But these are the 2 boxes that we'll be having through Small Planet, and they'll be selling these hopefully in the near future when we start getting our first shipments of these coming towards more the end of this year. The M-Sense, this is our essentially way of monitoring the room. So we've gone away from a more traditional thermostat. Instead of having a screen or something that you're programming, we put a sensor only in every single room or every single zone. So typically with radiant cooling, we mostly stick to everywhere but bathrooms, depending on the type of bathroom, how large its size, how good the ventilation is, just because the response times of changing ceiling panel temperatures were very fast, much faster than floors. But it's still, even if we cut off the water flow to that ceiling, the quick time that you're going to have a humidity change when somebody takes a hot steamy shower is too fast for us to respond. And so you can get increased condensation forming on a ceiling in a bathroom. So typically we make bathrooms heating only most of the time, unless they're large master bathrooms. But these sensors, they go in the wall. They're a 2-inch hole that you will cut in the wall. We give you a metal sleeve and a tool to install these. They go 0-inch mount technology, which Essentially, the sensor mounts completely flush with the wall, minus a quarter of an inch about, or an eighth of an inch that sticks out from the wall. The reason we have to have that 1/8 inch sticking out is because we have to allow some airflow through the sensor due to the types of sensors that we have in this single sensor. So we've got operative temperature, which is in the middle. This is the center disk. That's what we read. We read essentially a radiant type of temperature. So we find this is much more in tune with what your body feels in a space, especially when you have a radiant heating and cooling system. We do read air temperature, but we don't actually use that for our set points. Instead, we use the operative temperature. The air temp is used along with humidity to calculate dew point. So we use the dew point temperature to essentially control what water we're constantly choosing to run to the panels, especially when it comes to the cooling side, to avoid condensation on the ceiling. The other nice thing about the sensor is that it has an air quality sensor in it. So we actually have a total VOC. So we're actually reading volatile organic compound, and we're reading a ppm readout for that. And then we can, from that, there is a way to predict what CO2 level is, and they call it eCO2. So using the VOC sensor, we can give you VOCs, and we can also give you eCO2 readout and a part per million readout. And what's nice about having all of this in one sensor is that if we do have some type of air system, whether it be, say, an ERV or an HRV, then what we can do is we can actually choose to not have that ERV or HRV running all the time. So like, let's say a Zender unit that Small Planet would provide. If you chose to install one of those, you could choose to have us control that ERV and essentially turn the ERV only on when their air quality in a certain room has actually gone above the threshold that you specified for it. So this means you don't have to run that ERV 24/7. So this becomes another way for us to kind of be more efficient in the way that we're using things and actually only run stuff when we actually need it in that space. These run over Modbus. They get daisy chained back to the M control box. So either an MBOX 5 or an MBOX 10. They communicate through Modbus protocol, and they use an RS-485 connection on them. The air side. So we do offer air treatment units, but we also can control with these any type of ERV, HRV. We can control humidifiers, dehumidifiers, which is a big factor in doing radiant cooling in climates that have high humidities. So a lot of people go, well, can I do it? Well, yes, you can, as long as you control the humidity in that home. And that's going to be done through some type of air unit, whether it be a combi unit like the one that's shown here that does HRV, dehumidification, and supplemental heating and cooling all in one single unit. Or you could do some hydronic fan coils that we can run on the very low speeds to pull some moisture and act as a dehumidifier, but also supplemental cooling to a space, or just a single ERV if you live in a climate where like where we are, our office in SoCal, California right now, we don't typically need dehumidification to run cooling almost ever here. So we could get away with just an ERV or an HRV to do mechanical ventilation and just allow the panels to fluctuate their temps as needed, and knowing that most of the time we'll be able to run 50 to 55 degree water without having some type of dedicated dehumidification. This is a big part of what we kind of look at as the facets of what make up a building. So you got humidity levels, you've got air quality levels, and then you have the actual temperature in the space. And so we like to kind of try to be able to treat all of these, treat them all independently as we need. And that's from monitoring the different things that we get from our sensors, and then turning on the respective devices to be able to make those satisfied. So a few kind of the achievements that we like to proud ourselves in is that being a pioneer in the radiant cooling in the USA, it's something that honestly actually has been around in the US market for longer than people think, but it's mostly been on the commercial side and done in a very different way. Going into the residential, it's a lot more demanding than commercial honestly typically is, because of the quick changes that people will make within a home. And we pride ourselves in kind of educating and bringing the entire HVAC industry into understanding the possibilities with radiant ceiling systems. And one of the big ones with that we get all the time, especially, you know, we go to say a trade show, and this one always comes up, which is, well, heat rises. Well, as Alessandro talked about earlier, heat just goes hot to cold, no matter what, no direction, it doesn't matter. Hot air rises, and that's where I think people get mostly mixed up on. And then that you can do, we've shown that you can do condensation-free cooling on a ceiling system. And so even on floors as well. Typically with a floor, though, we're a little bit more less aggressive in the water temperatures that we run, but it is possible. And the key to this is monitoring the entire environment all the time and making those changes to water temperatures. And that's where the control platform is so critical. And being a developer of what we consider to be the first hydronic, fully customizable and modular control platform that's out there for any type of hydronic system. And what I want to do is just show a few different examples. So we are a worldwide company. These are some really good ones that we recently got pictures from in Auckland, New Zealand. And this is our partner there called Waterware. And so these are some of the homes that they've done. This is the finished product. This is some during construction here. So they have different panel layouts here, things that they were avoiding in certain areas, but you can see most of the time it's not 100% coverage. Some of these rooms do have pretty high coverage though. They typically don't do air treatment units on there, so they do tend to lean more towards the side of more panel coverage than necessary to make up for the times when we have to run warmer water. This is another install that was done in Auckland. And this is an office from an architectural firm also in Auckland. And then some recent ones from here in California. This was a smaller home in Palo Alto. They had hydronic ceiling panels and a couple of hydronic fan coils, one for this main room as an example. They had higher loads than the panels could do in that particular area based on the calculations. This is a very large home in Atherton that's got hydronic fan coils and radiant ceilings and a few radiant floors throughout it as well. These are all, both of these are air source, air to water heat pumps that are creating the hot and cold water for them. This is another home that was done a few years back in Palo Alto. This one's actually gas heat pumps from Rober. Some finished pictures of it, and then some pictures of earlier on during construction. Now you will notice in this picture that the panels are slightly different here. This is actually the one that came with gypsum. So this was a much older install. We predominantly only sell the NK panel now in the US just because some stuff I mentioned before about, you know, who hangs this panel. Drywallers would get a little like, oh, I don't want to touch it. And hydronics guys would say, I don't hang drywall. So now we have that nice separation of trade with the current NK panel. And just the different types of homes that we can do, from, you know, modern homes to a more contemporary style, more estate look to it. And so this is actually what the original classic panel. So you can see these cutouts here. This was actually where you used to have to make the connections between the panels. So this is actually one of the first panels that came to the US. But we've always liked showing this install because it's a very, very cool house that at the end, you know, did not have ventilation ducts or you know, large HVAC ductwork throughout this house wasn't really an option for them in the design style of it. And so it's always been one of our favorites. So I think that's kind of everything I have. So I think we'll kind of go through some questions that are in here. I see that, let's see here, let me open it up. So from Scott, he's asking how much of the comfort is based on the radiant energy versus the actual interior air temperature. They both play a role, but surprisingly, the radiant is far quicker. I mean, the best way I can describe it is if you've ever been out in the shade underneath the tree, which I'm sure everybody has, and you're a certain temperature there, you feel comfortable. And the air temp's no different underneath that tree than it is right outside of it in the direct sunlight. And as soon as you move into that direct sunlight, you feel immediately warmer. That's thermal radiation from the sun. So obviously on a much, much greater magnitude. Another example that I like to use is, you know, skiing in the springtime. So you might still have 45-degree air temp, but it's a sunny bluebird day and you're totally comfortable wearing a t-shirt on the side of the mountain. So thermal radiation is a much greater impact, in my opinion, than air temperature is, which is why it's having a very fast responding ceiling panel like ours, where you can pump water to it and you can get the ceiling surface up to a temp or down to its temp within a span of 10 to 15 minutes, allows you, even though the air temp in that room has not changed, you feel warmer right away as soon as that panel gets up to temp. So that kind of goes over that one. And then there's another question from Scott about the max BTU output at 46 degrees. That might be a different panel that you're looking at, because I don't know if that's the NK panel document. There's on our website, radiantcooling.com, which is going to be ported over to a new website when all of this new control gets released. And so there'll be a lot of new documentation for the new panels. But there's a submittal for the NK panel, and that's the numbers that I gave on there. So you might be looking at the classic panel. Do you have an example of passive house projects where these panels are used? Passive house typically cooling dominant due to high insulation values and tight infiltration. We do have a passive house that it was done. It's actually typically much easier because a passive house might be more cooling dominant, but the loads are typically much smaller than most of the high-end residential homes that we typically do that are not passive house. So usually passive house is actually a really great option for this type of system, just because you're definitely going to want really good ventilation and monitoring air quality because you're so tightly sealed. And so we have you covered there. And then the other side of things, which is that typically just the heating and cooling loads for passive houses overall, period, compared to a normal home, are going to be much, much lower across the board. And so typically with this type of system, it's super easy for us to meet those kinds of loads. What's the warranty on the in-panel controls? Easy repair, replace? How disrespectful is it to place? So the warranty on the panels, typically everything gets installed and air pressure tested to 100 PSI with air. So any leak that you would have is going to be found there. So if somebody didn't insert a fitting all the way, if somebody punctured a line somewhere already, they would find it. Then typically installers put water in, and then they leave water pressurized to a higher PSI, like 60 PSI as an example, until the drywall is fully hung. Because during that time, as they hang the drywall, if there was to be a screw, for instance, punctured the panel, which really you shouldn't have happen, because that means they didn't put a screw actually into the furring channel and they're not securing the drywall up. But we all know that it happens. And essentially they'll catch it then because they'll have water come out. It's very easy actually to repair the panel. Essentially, they just go ahead and they remove a section of the foam where the penetration and the tubing was. And then you can use a small PEX coupler to essentially bridge that gap where you made that hole. Otherwise, you could theoretically remove the entire panel, but it's not necessary to do. If there ever is a leak down the line, like somebody decided to drill a hole in the ceiling and accidentally didn't realize that there was a panel there and hadn't checked, same thing, you would have to remove a section of drywall around where that leak was. And then you would remove a section of the EPS foam to make room for the coupler. You'd cut the pipe, insert the coupler, and you'd repatch the drywall and pretend like it never happened. So it's very easy to replace or repair if need be. It's all removable if it ever needed to be. It's not something we see happen very common. It's something that happens maybe during the construction phase, but then gets fixed typically then. Is it possible to use M-Air as a makeup air unit? It is not. They are not designed to that type of CFM. If you have a makeup air unit, typically you're needing to make up more than 400 CFM of air. So a lot of the time this is a case where somebody put 1,000 CFM kitchen exhaust in, and you're going to need a lot more than our air treatment units, as an example, would make up, because our largest unit's 600 CFM, but when it does ventilation, it's actually only ever doing 300 in and out of the house. So typically we're right off the bat cannot do that. So we never ever use them for that. can be used for bathroom exhaust if you want to plumb just the stale air to like multiple bathrooms. So like on that 600 CFM unit, as an example, we're going to get 300 of stale air exhaust, and you could pull all of your stale air from say 3 different bathrooms, and you'd have 100 CFM of air being pulled out of those bathrooms. How much will square feet of panel be reduced with 46-degree water versus 55? The output of the panels, which let me actually, I'll go back to that page right now real quick. It's pretty noticeable to be able to run 46-degree water. You're getting 10 BTU more. So you're getting almost 50% more output of the panels. By going to 46-degree water, we don't like relying on 46-degree water because one, with most heat pumps, they're not going to maintain 46-degree water in a tank all the time. And two, typically most environments, even in low humidity, they're not going to want to always have the humidity that low. So generally we like to shoot for the 50 to 55 mark. We find it kind of that sweet spot in efficiency from heat pumps, as well as the sweet spot in kind of comfort. You don't want an environment too dry to be able to run super cold water, because that's part of what we could deem to be comfort in the home. So that is a big factor that we see have. Most of the time, 46 is kind of the bare low end. So in really dry climates, you know, like maybe you live in the Arizona in the desert, yeah, you could get away with 46 probably more often, but then at the same time, you've got hot outdoor temperatures that are going to make it more difficult for a heat pump, unless you're going geothermal as an example, to be able to maintain a 46-degree tank all the time. Let's see, last question. What is the effective energy recovery of our ventilation unit? So ours, I believe off the top of my head, is around 90 something. We only have HRVs available, and that's because in our combi unit, as an example, because we have a compressor in there, to be UL listed, there's different requirements for fire and whatnot, in case something was to happen with that compressor. And so therefore, we're not actually able to use ERV elements inside those units. It has to be a metal element, so we have to have HRV, but I believe it's about 90, 91%. So it looks like that's all the questions that we got. Don't think there's any ones that I missed on here.
Yeah, we'll give people maybe one more minute to come up with any questions. Also want to make sure that people remember that we're going to go ahead and send a copy of the presentation, or a link to a copy of the presentation and the video Tuesday of next week. We'll also try to capture the Q&A. If you happen to have a question that you forgot to ask, you can send your question to me, Eva, at smallplanetsupply.com, and I will forward it to Brian or whoever the question is for. It looks like we still have one question here from Scott. So if you wouldn't mind, oh, well, we hear the air units. I'll work on that while Brian asks your other questions, Scott. If you could do the warranty, Scott.
Oh yeah, let me, I'm gonna have to pull up the website because I honestly don't know it off the top of my head exactly, but I believe it's about, we think we have a year standard manufacturer's warranty on the panels. If you do want to read the entire warranty for all of our products, you can go to radiantcooling.com and go to the download section, and the terms of use for the app, the Messana controls warranty, everything is there.
Okay, and I got a question, an answer to Scott's question, and yes, especially for you, Scott, we will get it on request if we don't carry it as an in-stock item for air units. So I think we're almost at time. We're 2 minutes early. I want to thank everyone for joining us today. It was really great to have you here. And I want to thank the folks at Messana for coming and doing this webinar for us. And again, if you have questions that you forgot to ask, just send the questions to me. It's Eva at smallplanetsupply.com. And thanks for joining us today.